Yeah, hi. Welcome to today's class. Today we are going to be looking at how to solve quadratic equations using the quadratic formula. I mentioned in the last class that we have 3 to 4 methods to solve quadratic equations. But one thing that you must take note is that not all quadratic equations can be solved using the factorization method. And the way to bypass that challenge is to use what we call the quadratic formula. So the quadratic formula can solve every kind of quadratic equation, or probably as someone that is you've not perfected how to use the factorization method, and you are not told to solve that particular quadratic equation using the factorization method. I would advise to use the quadratic equation and the quadratic formula to solve it. The quadratic formula is very simple. It's simply based on the premise that each of our expressions is under a particular alphabet. For instance, we believe that a quadratic expression has the term ax squared plus bx plus c. So the expression minus b plus or minus the square root of b squared minus 4ac over 2a is simply a derivative of this particular equation. Now, how we arrived at this equation is using the completing the square method. I believe in another video we'll touch on how to use the completing the square method. But we are going to be used, so we call this the quadratic formula. So quadratic formula solves every kind of quadratic equation. Are you getting me now? So we are going to solve this particular equation using the quadratic formula. Like I said, each of the various constants in this expression is assigned to each of the various alphabets we have in the quadratic formula. So let's move on and let's solve what we have here. So let's find out the value. So A here is 3, B is minus 11, and C is minus 4. So let's put all of these values into our equation. We have B is minus 11, plus or minus the square root of b squared. B squared is minus 11, so minus 11 all squared minus 4. A is what? 3, and C is minus 4 over 2a. So 2 multiplied by 3. So when you bring these all together, you have 11 plus or minus, because minus times minus give you plus. So you have the square root of minus 11 is 121, minus 4 times 3 is 12, 12 times 4 is 48, minus times minus will give us a plus. So this is plus 48 over 2 times 3 is what? Is 6. So this is what we have so far. Now if you perform the various operations here, you should have 11 plus or minus the square root of 169. That's 121 plus 48. You have 169 over 6. Now let's move to the side of the board. So if you take the square root of 169, you will have 13. So we have 11 plus or minus 13 all over 6. Now, this plus or minus, you ask me why do we have plus or minus? So what we're simply going to do is that we are going to perform 2 operations. And the 2 operations is to perform the addition and the subtraction of this expression. So we're going to say 11 plus 13 over 6, or 11 minus 13 over 6. Now we do this because the value of our x in the quadratic expression, there are usually 2 values that your x can have in a quadratic equation. Are you getting it? And that's what we are trying to achieve. So when we do that now, 11 plus 13 here is 24 over 6, or minus 2 over 6. Now if you reduce the nearest, or you reduce this to the nearest term, you have 6 here 1 and 6 here 4. So you say 4, or now if you divide this by 2, So you're going to have 4 or minus 1 over 3. So we see x equals to 4 or minus 1 over 3. I believe you agree with me that the quadratic formula is very easy to use to find any kind, to get the solution to any kind of quadratic equation that you can solve. And one thing I want to mention to you is that it is possible to get fractions or decimals as your answer for any of the work that you are doing. So pay attention. I look forward to seeing your reactions, to seeing what your feedback concerning this particular topic. There's a lot that you have learned, and I believe that you can apply this to solve. You can apply this to do any exercise. I look forward to getting your feedback. Please share with your friends and let them join this wonderful class. Thank you.